All right, y'all, welcome to concept 31, which is absolute value inequalities. This is a really cool lesson because it combines what we know about absolute value equations with what we know about solving inequalities, which was concept 29. So concept 29 and concept 30 combined give us concept 31. So there's a list of steps that we'll follow to solve absolute value inequalities. First, we are going to isolate the absolute value like we did before with absolute value equations. We are going to write the problem in two cases. One is positive, one is negative, similar to what we did again in absolute value equations. But the difference is that when we write the negative one, the negative case, we are going to flip the inequality symbol. We're going to change direction. And then we would solve both inequalities and graph them. Now, in these two boxes here, it gives us a general idea about what absolute value is and how it applies to inequalities. So if you remember that absolute value means distance from zero, you can see that in the first box, in the box on the left, it says the absolute value of x is greater than 3. So we're looking for numbers that have a distance between x and 0 that is greater than 3. So numbers like 4 and 5 and -4 and -5 are all more than 3 spaces away from 0. So essentially what we're doing is we're saying we have an inequality that doesn't include 3, but it includes everything less than -3. And it doesn't include 3 here, but it includes everything greater than +3. So all of the numbers that are covered by an inequality, not including -3 or 3, are solutions to this inequality. So if I put -4 in my absolute value, we're checking to see if this is greater than 3. Well, it is, because the absolute value of -4 is 4. And 4 is greater than 3, so this checks out. So all of those numbers are solutions to this inequality. Now, the cool thing is essentially what we have is we took my inequality, my original inequality, and wrote it two ways. I wrote it as a positive inequality here. This is our positive version. And here's our negative version. Now, notice that I flipped the inequality symbol when I made the negative case. I flipped the inequality symbol, and then those two inequalities are now graphed on my line. I have an open circle here. I have an open circle and it's going to the left, and on this one I have an open circle and it's going to the right. So I've just graphed it. When my inequalities are graphed and they're going in opposite directions, they're going away from each other, this is an OR inequality. So we need to make sure we put OR in between. So that's how that works. In the second case on the right, say I had the absolute value of x is less than 3. So I'm looking at numbers that have an absolute value or a distance from 0 that is less than 3. So I'm referring to the numbers here. All of these numbers, the absolute value of them is equal to a number that is less than 3. So it's similar to what we had previously, but we're talking about all the numbers that are in between -3 and 3, but not including -3 and 3. If you'll notice that in this inequality that we wrote, when we wrote it as a negative, we flipped the inequality symbol, and we essentially graphed the two. Now, this, because we have an inequality, two inequalities that are facing each other, this is an AND inequality. And ANDs can be written as a special way. If we put the absolute value in the center and I put my lowest value on the left and my highest value on the right, I know that they are related in this way. They compare in this way. When I'd use less than symbols for both cases. And of course, they're open less than symbols because the circles themselves are open. And that's how we go about finding and graphing inequalities that have absolute values. Let's take a look at a few examples of equations, absolute value, inequalities, and we'll graph them and see what we get. So similar to, again, similar to absolute value equations, I need to write a positive and negative version. After my absolute value is isolated, which it already is. So now I have x minus 8 is greater than or equal to 9, and x minus 8 is now less than or equal to negative 9. We are going to make it negative and flip the inequality. From here, I need to solve by adding 8 on both sides here and doing the same on both sides here. So you see it's very, very similar to absolute value equations that we just did, but now we are dealing with inequalities. So 9 plus 8 is equal to 17, and on this side, negative 9 plus 8 is equal to negative 1. So now we have two inequalities. We're going to graph them. In order for us to figure out if it's an or an and, we need to look at the graph. So if I have the absolute value, if I have x is less than or equal to negative 1, I know I'm going to have a closed circle on negative 1, and my arrow is going to go to the left, because that's where my inequality is pointing. Now 17 isn't on my graph, but imagine it was here somewhere. I would have a closed circle and go to the right. So this is an or, right? They're going in two different directions, so we would put an or in between. That's that. When we get to the second example here, again, I need to write two versions. I need to write positive and the negative version. So 2x minus 5 is less than 4, so it hasn't changed too much. And then I have 2x minus 5 is greater than negative 4. So I'm going to now solve my equations using the same steps for both, solving my inequalities rather. I'm going to add 5 to both sides, add 5 to both sides, here and here. And I get 2x is less than 9, 2x is greater than 1, and finally I need to divide by 2 to isolate x. Divide by 2, divide by 2, and I get x is less than 4.5, and x is greater than 1/2. Don't freak out because they're fractions, it's okay. We can still graph them. So we need to figure out if it's an and or an or. So at 1/2, I have an open circle. Sorry, it's negative 1/2. At 1/2, I have an open circle, and it's going to the right. And at 4.5, I have another open circle, and it's going to the left. Now, what's happening is they're meeting in the middle and creating one single line. So we can actually just draw it as one single line. So this must be an and inequality. And I know that with an and inequality, I can write it as a compact or combined inequality, such as this. I put my less than symbols because the circles are open. I put my lowest number first and my highest number last, and there you go. We'll do one more example where we have to do a little bit of isolation first. So very similar to what we did previously. I need to subtract 2 on both sides here. So I get 5 times the absolute value of 6 minus x is less than or equal to 35. Well, I also know that I need to divide by 5 to get my result, get my inequality by, or my absolute value by itself. Now, here is where I need to split it into 2 equations. I've isolated my absolute value, so I'm going to make a positive and a negative version and solve both. So I have 6 minus x is less than or equal to 7, and I have 6 minus x is greater than or equal to negative 7. I'm going to move those over here so I can solve them. So 6 minus x is less than or equal to 7. Oh my gosh. So I need to first, actually let me write my other one here. 6 minus x is greater than or equal to negative 7. Like before, I need to isolate, so I'm going to get the 6 by itself, the x by itself, by subtracting the 6 on both sides. So negative x is less than or equal to 7, and negative x, not 7, 1, 7 minus 6 is 1, and negative x is greater than or equal to negative 13. Well, I want to know what x is, not what negative x is. So in order for me to get my x by itself, or to make my x positive, I can either multiply or divide by a negative number. In this case, negative 1. So I'm going to divide by negative 1 to make my x positive. So x is less than, oh, wait a minute. When I divide by a negative number, my inequality symbol changes direction. So this becomes greater than or equal to negative 1. 1 divided by negative 1 is negative 1. And x here is now less than or equal to, changing direction, positive 13. I would then go, of course, to graph this equation, or graph these inequalities. I have an inequality at negative 1. It is closed, and it's going to the right. And I would have an inequality at 13 somewhere here, going to the left. So we know that this is an and inequality. So we would say and in the middle, and we would write our inequality such that it displays how x compares to negative 1 and 13. It's actually in between. And that's concept 31. Very similar again to 30 and 29. It's just combined. And that's that.